Hello students, today we are going to talk about the cathode ray experiment. The cathode ray experiment, conducted by J.J. Thomson in the late 19th century, was crucial in the discovery of the electron. But before Thomson's experiment, the atom was thought to be indivisible. However, certain phenomena, such as electricity conduction in gases, hinted at the presence of smaller particles. Let's check how did he do that, and what did he use. Thomson used a glass tube, from which most of the air was evacuated to create a near vacuum. The tube contained two metal electrodes, a cathode negatively charged and an anode positively charged. He used a high voltage of power supply that was applied across the electrodes. When the voltage was applied, a beam of light known as cathode rays was emitted from the cathode and traveled towards the anode. Let's check the observations. Thomson placed an electric field across the path of the cathode rays. The rays were deflected, confirming their charge. This deflection allowed Thomson to measure the charge to mass ratio EM of the particles. He also placed a magnetic field perpendicular to the path of the cathode rays. He observed that the rays were again deflected, indicating that they were charged particles rather than light waves. By varying the gases in the tube and the materials of the electrodes, Thomson found that the properties of the rays, specifically the EM ratio, remained constant, suggesting that these particles were a fundamental component of all atoms. What did Thomas conclude after this experiment? Thomson concluded that cathode rays were composed of negatively charged particles much smaller than atoms, which he called corpuscles, later known as electrons. This discovery showed that atoms were not indivisible, as previously thought, but were made up of smaller particles. Thomson's work provided the first evidence of the electron, a fundamental subatomic particle. This led to the abandonment of the indivisible atom model. Thomson proposed the plum pudding model of the atom, where electrons were embedded in a positively charged pudding. That's it for today's video. Until next time, stay safe and keep experimenting.